In our last lesson, we talked about using the product of powers property and when we could use it. So we discussed that we could use the product of powers when we found a product with the same base, that we could add the exponents and use this exponent with the same base. Now today we're going to talk about the quotient of powers property, and our objective today is to understand this property and be able to use it. So let's get started. To use the quotient of powers property, we have to be able to take out a common factor from the numerator and the denominator, similar to what we did when we simplify a fraction. So if we remember, when we're simplifying a fraction, let's say we have the fraction 10 this. Both the 10 and the 5 have a common factor of 5, so we would divide both by 5. So 10 divided by 5 will give you 2, and 5 divided by 5 will give you 1. We're going to use the same kind of idea when we're working with the quotient of powers property. So let's pull 5 to the 5th divided by 5 to the 2nd. So what would this look like if I were to expand it out? So if I were to expand it out, I'd have 5 times 5 times 5 times 5 times 5. Because I had a 5 as an exponent and a 5 as a base, so that means I have 5 multiplied by itself 5 times. And this would all be divided by, 5 to the 2nd, which would be 5 times 5. Let's write this as a fraction, and so it'll be a little bit easier for us to talk about. So I'm going to take this piece here and I'm going to put it underneath. Having a hard time with my stylus here today, sorry guys. Alright, so now I have my 5 factors of 5 up on the top. So I have these 5 factors of 5 on the top. And I have my 2 factors of 5 on the bottom. Now there's a couple of different ways that you can think about this process of what I'm going to do. If we're going to link this back to what we did with the simplifying a fraction, we can divide both the numerator and the denominator by the same factor. So I have, since I have the same bases, I have 2 factors here where I have 2 factors of 5 on the top and I have 2 factors of 5 on the bottom, which will cancel each other out when I divide them out. So I would be dividing both the top and the bottom by 2 factors of 5 to cancel these out, leaving me with this 5 times 5 times 5, or 5 to the 3rd. What I notice here is I have a 3. And I started with a 5 and a 2. So it seems to me that when I have bases of both the dividend and the divisor are the same, I can subtract the exponent of the divisor. So that means that since I had 5 to the 5th divided by 5 to the 2nd, it gives me 5 to the 3rd. And if you take a look, you have 5 and 2. So that seems that 5 raised to 5 minus 2 will give you your quotient of powers. Remember, we had to have the same base. The base in both of these is 5, and then I can subtract my exponents. Let's try another example. So let's say we have 7 to the 4th divided by 7 to the 3rd. So let's expand this out to see what we're working with. So we would have 7 times 7 times 7 times 7, because I have 7 raised to the 4th, so that means I have 4 factors of 7. And I'm going to divide it by 7 times itself 3 times. So I have 7 times 7 times 7. Now, another way you can think of it, instead of dividing out a common factor, you can think about it like canceling. So if I see that I have 7 and 7 on the top and the bottom, because 7 divided by 7 would give me 1. So if I divide that, or I cancel it out, I'm getting a 1. So that would be 1, and then a 7 divided by 7 is another 1, and 7 divided by 7 is another 1. So you essentially are making this 7 times 1 times 1 times 1. But we don't need to write that because 1 times 1 times 1 still gives you 1. And 7 times 1 gives you 7. So we don't have to write this part. So we just end up with 7 to the first, which also can just be written as 7. Let's try another one. Let's try 2, well, let's write that in a different color. Let's try 2 to the 9th divided by 2 to the 6th. So my quotient of powers property tells me that since I have the same bases, I'm going to be able to subtract my exponents. So I would have 2 raised to 9 minus 6, which gives me 2 to the 3rd. So let's test that out using the method that we've been using. So I have 2 times 2, 9 times, 4, 5, 6, 7, 8, 9. Divided by 1, 2, 3, 4, divided by 2 to the 6. So I have 2 times itself 6 times 3, 4, 5, and 6. And so if we use the canceling method, I'm going to pair them up with another set of 2. So I have 2 divided by 2 gives me 1. I'm just going to cross them out. Make sure you line them up. If you don't line them up, you're going to lose some. And as you see, we have this left. So I have 2 times 2 times 2 times 2, which is the same as 2 to the 3rd. And my two answers agree, therefore showing that we got the right answer using our subtraction of the exponents.